number 2. Okay. We just need to wait for who? Ready?
Yeah, ready.
Good. So I wouldn't start without you. Okay, in number 2, I say find a vector, and it's a unit vector. So the first thing I know is I'm looking for x, y, z, and I know it's a unit vector, so what's its magnitude? Yes. So x squared plus y squared plus z squared equals 1. By the way, there will be people in this room which will forget what the word unit means by the time you get to the exam. Someone will put up their hand and go, "Teacher, what does this word mean? Unit vector." You're laughing now, but somebody will forget it.
Why did you tell me?
No. That's the type of person I am. No. Okay. I also say that x, y, z dot, what's the first vector I give you there?
I minus j plus 2.
That's the first vector in number 2, is it? So how many i's? 1. And j's?
Minus 1.
K's? 2. This, I tell you, equals 0. So this means x minus y plus 2z equals 0. I also say when you dot the vector with, what's the next one?
Minus 1.
Yep.
And 0.
You also get 0. So if you think about what's happened, we have changed these into 3 equations with 3 unknowns, x, y, z. Okay, so I think we maybe want to do something with the x or the y. I could get x from the second and the third and put it into the first. So from the last one, I can have x equals 3y and x equals y minus 2z. And I can put that into the first one. Replace them. Substitution. So now I get x squared. Oh, stupid. Sorry, did it backwards. It's not the x. I'm replacing the y and the z. So I need, what do I need? Sorry, I'm doing it too quick. Here I can get the x and put it in here to get y and z. And then with the y and z, now I'm confused. Oh, if only it was that simple. Oh, did I make this too difficult? Yes. Yeah, and cancel the y's. Then that'll leave me with x's and z's. I could write z in terms of x and yes. Let's see what happens. Maybe. So if I put these two together, multiplying this by 3, I get 3x yeah, I made this question too hard. 3x minus 3y plus 6z equals 0, and minus x plus 3y equals 0. So if I add them together, I get 2x minus 6z equals 0, plus 6z, of course. So x equals minus 3z. So that's x. Yeah, well, I'll put this into the first one, and then I need, here I can get y in terms of x. Yeah, actually, you know what? I think I'm going to rewrite this just as, instead of getting x, is getting z. So, z, 6z equals minus 2x. Z equals minus 1/3 x. Right. So, I'm happy with this. And then I'm going to look at this and get y. 3y equals x. So y equals 1/3 x. Now we're talking. Right, that's what I was trying to get at the start. Now that we have y and z with x, we can put this into the first one. These two here, this can go into the first one, and this can go into the first one. So we'll just have x, x, and x. So I have x squared plus y squared plus z squared equals 1. See, I replaced the y and the z with these two. 11 over 9 x squared equals 1. So that means x equals plus or minus, although I think in the answer I only took the plus. X equals 3 over root 11. That's the x. So that means y equals 1 over root 11 and z equals minus 1 over root 11. So there are the x, y, and z. But, in fact, I know this is one of the reasons this answer is wrong as well. Well, I didn't say in the question I only wanted the positive answers. It should be plus, minus, minus, plus, really. There should be. I didn't put it in my answer at the back.
The answer looks weird. It's like 1 over 4.
Very different, I believe that, yeah. I think it's, well, you know what? I'll just open up the new version here. Science and engineering, vectors. Dot product. Dot product, isn't it? Let's see what we get. So you can see that I've changed it, but I think it's actually number 3. Is that the same numbers? 1 minus 1 2 and minus 1 3. Yeah. Still totally different, huh? I don't think so, because I had... Oh, well, hang on, actually, I have root 11, but this is root 44, so I can take the 4 out, and it's a 2. Is my first answer a 3? It is, yes. It's the same answer, it's just I did not clean this up, that's all. But it is the same answer. Is this what I have in the old version? Except the plus and minus. Yeah, okay. Yeah, that's right. No, this hasn't been simplified. The answer should be 3 over root 11. If you type in 3 over root 11 as a decimal, and if you type in 6 over root 44 as a decimal, they'll both be the same number. Well, there's 2 possible answers, plus or minus. So vote.
Are we get something like this?
Besides the bracket, it's minus 6.
Yeah, I shouldn't. -6, and you can see that I have plus or minus 3. I mean, it's the same thing, Ali. If I have plus or minus -6, that's the same as plus or minus 6. I know it looks a bit messy. I should really clean that up. These should all be divided by 2 because I can cancel this. It's probably the same thing here. Can you divide 352 by 4? No, you can't. Can you? 352 divided by 4 doesn't... Does go?
Yeah.
Okay, in that case the same thing happens here. These can be cancelled by 2. No, not here. Although... No, not 9. No, actually, so these 2 here I can clean it up a bit more. Now, for the exam, you could get something as difficult as this, but I've only seen that happen once. I don't know, it's in one of the past papers. So, as you can see, these problems are quite difficult, but they're not impossible for the exam. They're just unlikely.
This is section B.
Section B. Now, if you've got something like this in the exam, you will get, it's not so bad, you will get lots of marks for it. Okay, so this could be like, this question I just did here, if it was in the exam, it'd be something like 6 or 7 marks. So I mean, you could get on the exam. It will be in section B because it's not short. And I know it looked tricky and I did make a bit of a mess at the start. It was a bit difficult to figure out the best way to solve them together. But yes, it could happen in the exam. And in fact, I do think the vectors question is usually okay in the exam, but a lot of students don't like vectors, so they don't do it. You are probably the same. Not like vectors? You have to do vectors, okay. Let's go on to the next topic, so write that down please. I'm going to print these new worksheets out for the extra class later. They're nearly the same, but as you can see I made some small changes, like I added in an extra question here. I think I changed the last one a bit maybe. Anyways, did you write that down and we'll look at the angle now. Okay. Right, so here's our problem we're looking at. We have 2 vectors, A and B. And firstly, let's just say that they're not 0 vectors. So A is not 0, 0, 0, and B is not 0, 0, 0. So they actually are 2 non-zero vectors. Okay. What type of vectors are these? What are they called? What type of vectors are they? What type? We've only done 2 types. No. First type we did was Euclidean. And then the second type we did was, begins with a P. Begins with a P. Possibly position vector? Yes. What's special about position vector? It's from, well, we don't call it 0. From origin, or center. From origin. So are these position vectors? Yes or no? You do know. Are these position vectors? Yes or no? Yes. Why are they position vectors? There's no first letter, which means that they start at O. So in fact, this is OA and OB. So if I draw it, it's like this. Here is OA, and then here is OB. And I'm looking for this angle here, theta. Okay. This is the vector OA. This is the vector OB. And which vector is this? AB. We pretend we know A and B. This is the information we're given. So if you want, we can just say A is x1, y1, z1, and B is x2, y2, z2. So x1, y1, z1, x2, y2, z2. If I know the A and the B, could I know this length here? Could I know the length of this vector? Is it possible to know this?
Yes.
Yes. Because I know what the A is. It's the magnitude of OA. Could I know the length of this vector? Yes, I could. And what about this vector? Could I know the length of AB? Yes. But I don't know what AB is. Yeah, B minus A. So I could know it. So if I have three sides and I would like this angle here, what trigonometry rule is that? Cos. Yep. So we have AB squared equals OA squared plus OB squared minus twice OA OB cos theta. So that's good. It gives us a way to calculate the theta. If I rearrange this, I can get cos theta equals AB squared minus A squared minus B squared all over minus 2AB. I can clean this up a little bit. This will be magnitude of, so these are all vectors of course, A squared plus B squared minus, now AB is B minus A squared all over 2AB. Let's change these to dot products. So the magnitude of A squared is the same as what dot product problem? A dot A plus B dot B minus B minus A dot B minus A all over 2 A dot A times B dot B. Now I'm not going to bother writing the little arrows on the top because we know these A's and B's are vectors. And I can expand this because we learned that earlier. A dot A plus B dot B minus B dot B minus and minus is plus B dot A minus and minus is yes, plus A dot B minus minus and minus is minus A dot A all over 2 A dot A B dot B. Now if you look at the top, we have things that go to cancel and so on. So the A dot A minus the A dot A goes. The B dot B minus B dot B goes. And here you have B dot A plus A dot B. But we also learned earlier today that B dot A is the same as what? Yeah, so you have A dot B plus A dot B all over 2 A dot A times B dot B. But on the top, this is the same, this is a number plus the same number. So it's just twice A dot B all over 2 A dot A, B dot B. And these cancel. Now let's remind ourselves, what is A dot A? What did we say that was? No, what else is it the same as, I mean?
A squared.
Magnitude of A squared. Magnitude of A squared. And then B dot B is magnitude of B squared. And that's it, that's our result. This is the formula which will give us the angle between two vectors A and B. And we'll do an example of it in a moment. And you can see why it's important that I said at the start the magnitude of A and B are not is not zero. Those magnitudes are not zero. Because if they were zero, then we'll be dividing by zero here. Anyways, we can't find the angle between two vectors if one of the vectors has no length. It doesn't make sense. And what's great about this formula is it works for I and j, or I, j and k. It doesn't matter if you're in 2 dimensions or 3 dimensions as well. So we'll do an example first in 2 dimensions. Can I scroll down? Yeah. So let's pick an example where we know the answer. So here's my first vector. Let me just call that vector 5i. And then here's my second vector. It's 5i plus 5j. Now I'm sure somebody can tell me what the angle between these two vectors is. What do you think this angle might be? Even just from the graph, roughly. No, the angle just. 45. So let's see if we get 45. So A is 5 and 0, and B is 5 and 5. And our formula is cos theta equals A dot B over magnitude of A squared, magnitude of B squared. So what's A dot B? 25. What's the magnitude of A? No? Magnitude of A? You forgot this square root. It's 5. And then we square it. And then what's the magnitude of B? It's square root x squared plus y squared, 50 squared, good job. So that means cos theta, well, what's 5 squared? 25, so that's gone.
1 over square root 50 squared.
Yes, so this is 1 over 50. So this isn't going to be 45. I thought my picture made it 45. 5i plus 5j. Did I do something silly? A dot B is 25. Magnitude of A is 5. Magnitude of B is 50. Wait. That's something went wrong here in my formula. I just not concentrating. I shouldn't have the squares in the denominator, so why did they not go? What? Oh, yeah. Here's the problem right here. Magnitude of A is not A dot A. It's a small slip here. Magnitude of A is, magnitude squared is A dot A. So what's magnitude of A? Square root A dot A. Can you see that? If magnitude squared is A dot A, then what's magnitude? It's square root A dot A. Sorry, so we're just missing in the denominator a square root. So square root, square root, square root, square root. So if I put a square root here, what happens to the squares? They cancel. Sorry about that, there's no squares here. No square, no square. Okay. A dot B is still 25. Now it's the magnitude of A, which is square root 25, and the magnitude of B, which is square root 50. Okay, if you type that in on your calculator, what do you get? 25 over root 25 root 50. Yeah. Square root 2 over 2. Therefore, what's the theta here?
45.
Pretend you typed it in on the calculator.
Okay, 45.
Yeah. What did you get?
45.
Great, yeah, 45. So I find it's always good advice if when you study something new in maths, you pick an example of something where you know what the answer should be, making sure you're not doing something silly. Yeah. Okay, so now we've seen this in 2 dimensions, so let's have an example of one in 3 dimensions. So here's one vector. Let's try my very best to draw 3 dimensions. I, J, K. Let's see. So in red, this vector here, it's on the ground. Can you see that? Will I add some colours in for special effects? This is on the ground. Oh no, that's ugly. On the ground. And we'll say that this vector is 1i, 1j, and no k's. Now, let's put another vector, and this will be very difficult for me to draw, but it is right above the red vector. And it's 1i, 1j, and 1k. So, if you were to shine a light down on this vector, it would make a shadow, and in fact it's directly above the red vector because it's 1i and then 1j and 1k, so it's right above the red vector. The red vector's on the ground. Yeah? I left my 3D glasses at home for you, okay? So you're going to have to use your imagination. But if I try here... Huh? Huh? 3D? You have 3D glasses? What?
No, I mean the things on the corner.
Yeah, well, if we use, like, I was trying to find something, but I guess the corner would do. So this red vector, if we think about maybe here, this one here is K, going up. This one here is I, and this one here is J. So the red vector is 1I, and then 1J. So this is the red vector here. Can you imagine that? And then the next vector is 1, 1, 1. So that's 1I, 1J, and then up 1K. So then the next vector is going up here. So we have one vector here, and then one vector here in 3 dimensions. So I think the angle again, in this example, if we can use our imagination, what would be the angle between these two vectors, do you think? Yeah, I think it will be 45. So I want you to calculate the angle here and see if you get 45. Now, you can't be certain because it's 3 dimensions, it's more difficult to imagine, but I think it should be 45 also. So why don't you check and see what you get? So I want to know this angle here. I'm trying to draw this for you in 3 dimensions. No, that won't do. Well, there's 1, 1, 1 anyways. And then the next one was 1, 1, 0. That's not good. No, that's useless. Well, no, it's just that I need the program to draw a line from the origin to the point as well. Anyway, it wasn't 45? Not 45 in this case, no? We said, but anyways, it should be close to 45. What did you get?
55.
Did you get the same?
I got it.
Okay, I better do it. So, cos theta, the dot product would be what? What's the dot product here?
2.
2, correct. And what's the magnitude of the first vector?
2.
Very good. And the second one?
3.
Yeah, so it's not 45 degrees here, but it still should be close to 45. So theta is, no, actually it still might,
Cosine inverse.
The cos inverse 2 over root 2 root 3.
Yeah.
So what do we get for this?
35.6.
What is it?
35.26.
Okay, 35.26. Yeah? Okay, try 1 or 2 for a couple of minutes, and while you're doing that, I'll see if I can get you super cool 3D vectors. Yeah, super cool, that's right. Ah, okay. This might do it. Now I have the two vectors drawn, but I'm trying to rotate this, so I need the x to be down here, and then the y is the wrong way around. Ah, now we're in business. Okay, look, here we go. I know I haven't got it drawn the right way around because I need to. It's not flipped around the right way. Oh wait, no, actually I'm getting it. Oh yeah, close enough. So this is the vector 1i, 1j, and 0k. And then you see this one here is the vector 1, 1, 1. So this angle, when I look at it, let me rotate it, you can see that the angle is, what did we say, about 45. What did we get, 35? Yeah. Look. Just like in the Matrix. Yeah. I know it's not PS4, but still. I hope it'll help you see the angle between the two here. Alright, that's enough playtime. We'll finish there.